The physical properties of the atmosphere. Before we can understand the implications of air pollution, we have to understand some of the principles of the atmosphere. Our textbook author provides a great amount of earth science information in Chapter 1. Equations, graphs, chemical notation, and psychometric charts are presented. For some of you, this may be a review. Others may find this all new, and maybe for most of you, a combination of both. In any case, I'm not going to ask you to perform calculations on gravity or determine the difference in the Coriolis effect on spacecraft launched from the Kennedy Space Center versus the European Union launch facility in Guyana. But you do need to understand there are multiple physical and chemical processes in systems affecting the movement of air and, of course, any contaminants that may enter the airstream. It is also important to comprehend the chemical makeup of the atmosphere. You should be able to discuss how it evolved, how it functions, and the impact of human activities on the atmosphere. Some of the topics in Chapter 1 include how global circulation is driven by energy from the sun. The most intense energy is received at the equator, where it warms the air. The air rises and flows north and south. This causes cooler air from around 30 degrees north and south latitude to move toward the equator. A similar process occurs between the mid-latitudes and the polar regions. There are many other influences affecting this flow, but the key is to understand how contaminants, that is, air pollutants, can flow from one part of the world to another. The atmosphere is dynamic. It evolved in composition from a mixture of carbon dioxide, nitrogen, and hydrogen to the present makeup of primarily nitrogen and oxygen and many other trace but important gases. The formation of water vapor in the primitive atmosphere paved the way for the formation of life on Earth. Scientists get very excited when water is discovered on celestial bodies because life as we know it cannot exist without it. As more water was created, eventually the oceans were formed. Yes, and that took a long time. Eventually, primitive microbes evolved to use carbon dioxide and sunlight to create complex carbohydrates, producing a byproduct, oxygen. Some of this oxygen was converted to ozone and created the protective ozone layer found in the stratosphere. The atmosphere continues to change, but this time man-made anthropogenic sources are driving many of the new changes. Over the next several weeks, we will learn more about these man-made substances and their impact to the planet.